Did you know that for Nikola Tesla, the universe was not a silent void, but a vast symphony of vibrations continuously humming beneath everything you see and touch? To Tesla, reality itself was not built from solid static objects, but from fields, waves, and oscillations, patterns of energy in constant motion. When he spoke of energy, frequency, and vibration, he was not offering a loose metaphor. He was pointing toward a structural truth about the cosmos as he understood it, a truth he tried to translate into coils, transformers, and towers that could make the invisible dance of the universe visible and useful. Nikola Tesla approached the universe like an engineer dismantling a complex machine. Where others saw matter, he saw configurations of energy. Where others saw empty space, he suspected a medium filled with subtle forces capable of carrying power, information, and even thought-like structures. His vision of a vibrating living universe can be traced through his inventions, his patents, his lectures, and his most quoted lines, especially the one that hints, "If someone wants to understand the secrets of the universe, they should think in terms of energy, frequency, and vibration." That sentence, often repeated today, was rooted in decades of focused experiments with alternating currents, resonant circuits, and high-voltage discharges. To understand what Tesla meant, one has to step into his laboratory and watch how he treated electricity. He did not merely use current, he tuned it. In the famous Tesla coil, for example, he designed a system where electrical energy oscillates between magnetic and electric forms, creating high-frequency, high-voltage discharges that light up bulbs at a distance, cause sparks to leap through the air, and reveal arcs of plasma tracing invisible field lines. This was not just spectacle. For Tesla, the coil was a proof of concept that energy could be transmitted without wires, not by pushing electrons down metal conductors, but by setting up resonant vibrations in the surrounding medium, like striking a tuning fork and making another tuning fork across the room, begin to vibrate. Imagine this: you are standing in a darkened room in Tesla's laboratory. Around you, metal spheres, coils, capacitors, and strange contraptions are connected in careful arrangements. Tesla adjusts a setting. The coil begins to hum. Suddenly, long purple streamers of lightning burst outward, yet bulbs held far away glow without any direct contact. To a casual observer, it looks like magic. To Tesla, it is resonance. He would argue that when a system is driven at its natural frequency, energy transfer becomes highly efficient, even across distance. This principle, he believed, was not limited to coils and transformers. It applied to the Earth, to the atmosphere, and perhaps to the entire cosmos. In Tesla's view, the Earth itself could be made to vibrate electrically. He once constructed massive oscillators and transmitters, not just to send radio signals, but to set up standing waves along the planet's surface or through its conductive layers. The controversial Wardenclyffe Tower, often mythologized as a free energy device, was in Tesla's own framing a wireless power transmission station. Its goal was to inject electrical energy into the Earth and atmosphere at specific frequencies, allowing receivers tuned to those frequencies to draw usable power remotely. Whether the physics as he conceived it was fully correct or not, the conceptual frame is clear. The planet was not a passive rock. It was an active participant in a global resonant system. This is where his idea of a living universe becomes more than poetic. Tesla did not necessarily claim that the universe is alive in the biological sense, but he treated it as a dynamic, self-organizing field of energy. Waves interact, resonate, interfere, and form patterns. Structures arise not because matter is rigid, but because underlying fields are ordered. When he studied lightning, geomagnetic disturbances, and cosmic rays, he interpreted them as expressions of large-scale energetic dynamics. To him, a thunderstorm was not just weather. It was a macro-scale discharge phenomenon within a planetary electrical circuit. When you hear modern physics describe the universe in terms of fields, electromagnetic fields, quantum fields, gravitational waves, the language may sound surprisingly close to Tesla's intuition. He worked before the full development of quantum field theory or general relativity became mainstream. Yet he insisted that the universe should be understood through continuous media, waves, and oscillations. His debates about the existence of an ether reveal this orientation. While the scientific community later abandoned the classical ether concept, the idea that empty space is not truly empty but filled with structure and potential is now embedded in discussions of vacuum energy, zero-point fields, and space-time curvature. Tesla, operating with the tools and theories of his time, reached for a similar intuition. Space is not nothing. It is saturated with energy and responsive to vibration. Tesla's fascination with frequency went beyond engineering convenience. Frequency, to him, was the key to unlocking control over energy. Low-frequency currents behave differently from high-frequency ones. They penetrate differently, interact with materials differently, produce different physiological and environmental effects. He experimented with high-frequency currents that could pass over the skin rather than through vital organs, leading to demonstrations where he seemingly played with electricity without harm. He observed that different frequencies could stimulate different luminous effects in gases, leading toward early forms of fluorescent lighting and wireless illumination. Frequency was not an abstract parameter. It was the signature of a particular state of energy. For a moment, consider how this worldview shifts your perception of reality. Instead of seeing a chair, a wall, or your own body as fixed objects, you see them as condensed patterns of energy, stabilized by underlying fields and interactions. Every atom is a balancing act of charged particles, every molecule a stable vibrational configuration, every solid structure a frozen pattern in a sea of motion. This is close to how contemporary physics describes matter, as excitations of fields, as quantized modes of vibration. Tesla's language of energy, frequency, and vibration, though less mathematically precise, anticipates this direction of thought. There is also a subtle spiritual undertone to Tesla's universe, even though his public statements remained largely technical. When he spoke of tapping into the very wheelwork of nature, he implied that nature is not random chaos but a coherent mechanism governed by principles that, if understood, allow one to harness power with minimal waste and maximal elegance. Many of his admirers later layered mystical interpretations onto his statements, but underneath, there is a core idea. The universe is structured, resonant, and intelligible through patterns of energy. To align with those patterns is to gain leverage over physical processes. To fight them is to waste effort and incur instability. For Tesla, the human mind itself did not stand apart from this energetic reality. Thought, in his view, was a form of vibration. Inspiration was a kind of resonance between the brain and the wider environment. He spoke about ideas arriving in complete form, as if downloaded from an external source, and he preferred to visualize entire machines in his mind, running them through virtual tests before ever touching material components. In modern terms, one might say he treated consciousness as a complex dynamical system embedded in a larger field of information and energy. From this angle, what you call intuition could be described as a resonance phenomenon between the patterns in your brain and the larger patterns in the world. If you place yourself inside this worldview for a moment, the universe begins to look less like a collection of separate things and more like a single, interconnected process. Every action radiates outward as waves. Every object participates in the field. Every system has its own natural frequencies. To understand anything deeply, you would not only measure its size or mass, you would study how it vibrates, what frequencies it responds to, what patterns it sustains or disrupts. That is the essence of Tesla's vision. A vibrating universe where energy and information flow in waves and where technology is, at its best, the art of tuning into those waves rather than forcing them. As his experiments progressed, the logic of vibration and resonance became more than a set of engineering tricks. It became a framework for interpreting events across scales. When Tesla tuned circuits to resonate, energy began to accumulate with striking efficiency, just as a child pushing a swing at the right moment can drive it higher with minimal effort. The same principle explains why a singer can shatter glass at the correct pitch, or why a poorly designed bridge can oscillate dangerously under rhythmic forces. To Tesla, these were not separate curiosities but manifestations of one underlying pattern. Every system has a natural frequency, and when driven at that frequency, its response is amplified. In his laboratory, this principle took on dramatic form. Tesla's high-frequency transformers and oscillators showed that when electrical systems are tuned to resonance, voltages can climb to extraordinary levels without equally extraordinary power input. Coils would begin to glow, sparks would lengthen, and remote devices would activate as if touched by invisible hands. This deeply impressed upon him the idea that the universe favors resonance over brute force. Why push harder, he would effectively argue through his work, when one can push at precisely the right rhythm and let the system itself do the amplification. His experiments with mechanical oscillators extended this intuition. There is the well-known story of the compact mechanical device he attached to a structure, allegedly causing significant vibration through resonance. While the details have been embellished over time, the principle is sound. A small periodic force, if synchronized with the natural frequency of a large structure, can induce powerful oscillations. When you consider your own life, this logic applies metaphorically. Continuous small inputs at the right frequency often have more impact than sporadic bursts of effort. Tesla's universe, whether mechanical, electrical, or human, responds most strongly to coherent, rhythmically tuned influences. On the electrical side, his dream of large-scale wireless power transmission rested on the assumption that Earth and its surrounding atmosphere form a resonant system in their own right. Just as a cavity resonator in a lab can sustain standing waves of specific frequencies, the planet and its conductive layers can support certain global modes of oscillation. Tesla saw Earth not as an inert sphere, but as a vast resonant body that could be driven with appropriately tuned pulses, allowing energy to be injected at one point and extracted at another, provided that both ends were synchronized to the same oscillatory pattern. In this way, Wardenclyffe Tower was designed not as a symbolic monument, but as a physical interface to the planet's own energetic behavior. It combined a deep-grounded structure with a towering conductive mast, aiming to couple electrical energy into both the Earth and the atmosphere. Tesla envisioned synchronized receivers across continents, each resonating with the same frequencies, drawing power as easily as a radio antenna draws signal. Whether the practical limitations, economic pressures, and competing technologies made this vision unworkable is a historical question. What matters for understanding his universe is that he treated Earth as a dynamic node within a larger energetic network, not as an isolated object. At the same time, his thinking reached beyond hardware into more abstract territory. Tesla was aware that what people call matter dissolves under closer scrutiny into patterns of charge, mass, and motion. Even in his era, it was clear that atoms are mostly empty space, that forces, rather than solidity, hold structures together. From that perspective, the distinction between matter and energy blurs. If all forms of matter can be described via configurations of energy, then describing reality in terms of vibration and frequency is not poetic excess, but a compact way of pointing to how those configurations are structured. You can see this in how he approached the electromagnetic spectrum. Visible light, radio waves, X-rays, and other forms of radiation were, in his view, variations within one continuous field, differentiated primarily by frequency. A radio transmitter, a spark gap, and a beam of light were different instruments in the same orchestra. This compression of diverse phenomena into a single conceptual framework, energy oscillating at different frequencies, gave him a sense that the universe is fundamentally unified, that apparently distinct processes are surface manifestations of deeper shared dynamics. This unifying tendency attracted him to numerical patterns as well. The famous emphasis on the numbers 3, 6, and 9, whether overstated in later retellings or not, fits within a broader pattern of seeking symmetry and order. Rotational symmetries, three-phase power systems, triads, and wave behavior, all of these suggest an underlying mathematical rhythm. Engineering three-phase alternating current systems, for instance, was not just a technical choice. It reflected a preference for balance and efficiency. Such systems deliver smooth, continuous power, reducing pulsation and waste. To Tesla, this kind of elegant efficiency echoed a larger cosmic economy where energy is not squandered but redirected through resonant pathways. From the outside, Tesla's blend of rigorous engineering and speculative cosmology can look contradictory. On one hand, he worked with precise circuits, measurable voltages, and clear experimental setups. On the other, he spoke of tapping into the deeper wheelwork of nature and hinted that subtle energies permeate space. In reality, his method maintained a consistent internal logic. Start with empirical experiments, identify patterns of resonance and efficiency, then extrapolate those patterns outward, assuming that nature repeats good designs across scales. You might call this a kind of analogical physics, seeing the laboratory as a miniature model of the universe. This approach naturally touched the boundary between science and spirituality. Tesla did not operate as a religious preacher, yet he expressed reverence for the order and intelligence embedded in nature's structure. When he spoke of the universe as a magnificent machine, he did so with both analytical clarity and a sense of awe. For modern listeners, this dual attitude can be instructive. It is possible to respect empirical evidence and mathematical precision while also acknowledging that the overall coherence of physical law evokes a form of wonder often associated with spiritual reflection. In this context, the phrase vibrating living universe acquires layered meaning. Vibrating points to the oscillatory, wave-based character of physical phenomena, from radio signals and light to atomic transitions and thermal motion. Living suggests that these processes are not static snapshots, but ongoing, adaptive interactions, constantly exchanging energy and information. When you look at galaxies rotating, stars pulsing, planets orbiting, and biological systems maintaining homeostasis via complex feedback loops, the language of dynamic, living systems becomes more than metaphor. Tesla's insistence on energy, frequency, and vibration can be seen as a precursor to modern systems thinking, where emphasis is placed on flows, feedback, and emergent behavior rather than isolated objects. For you as a viewer, this has a striking implication. The universe that Tesla envisioned does not place you outside the system as a detached observer. Instead, you are embedded within the same network of fields, forces, and resonances. Your nervous system operates with electrical impulses, your cells rely on gradients and fluxes, your brain rhythms synchronize with cycles of light and darkness. Even your technologies, phones, satellites, power grids, are extensions of this ongoing dance of waves. To adopt Tesla's perspective is to see yourself not as a separate entity floating in a dead void, but as a local pattern within a far larger, vibrating structure. From this vantage point, science becomes the disciplined attempt to decode these patterns, to identify the natural frequencies of systems, and to design interactions that harmonize rather than conflict with them. Tesla's career, with its mix of brilliant achievements and unrealized ambitions, illustrates the power and the risk of this approach. When resonance is understood and respected, the results can transform entire civilizations, as with alternating current power systems. When the surrounding economic, social, or technical conditions are misjudged, even visionary projects like Wardenclyffe can collapse, leaving behind only partially explored ideas. Yet the conceptual legacy persists. The universe as a continuous resonant field of energy, structured by frequency and vibration, within which technology is the art of tuning. And the lingering question is whether humanity has fully grasped the implications of that vision, or only borrowed fragments of it to power lights and screens. When you trace the arc of Tesla's thinking forward into modern science, the resonant, vibrating universe he intuited becomes even more striking. Electromagnetic theory, fully developed through Maxwell's equations, already describes light and radio as waves propagating through space. Quantum theory goes further, describing particles not as tiny billiard balls, but as excitations of underlying fields, each with characteristic frequencies and energy levels. In solid-state physics, The behavior of crystals and materials is analyzed through lattice vibrations, phonons, again invoking frequency and resonance as central concepts. In this landscape, Tesla's insistence that energy, frequency, and vibration are keys to understanding reality does not sound mystical. It sounds like an early, less formal expression of what would become the dominant language of advanced physics. Consider, for example, the way modern science describes the energy levels of electrons in an atom. Electrons do not occupy arbitrary orbits. They inhabit discrete energy states, and transitions between these states involve the absorption or emission of photons at specific frequencies. The atom is, in essence, a quantized resonant system with allowed vibrational modes determined by the structure of its fields. Radiation itself is described as packets of energy associated with particular frequencies. Here, frequency is not merely a descriptive label. It is fundamentally tied to how much energy a given quantum of light carries. This deep linkage between energy and frequency would have aligned neatly with Tesla's fascination. To change the behavior of a system, you adjust its frequencies. At larger scales, similar logic appears. The Schumann resonances, global electromagnetic resonances excited by lightning in the cavity between Earth's surface and the ionosphere, illustrate that the planet indeed supports standing wave modes, much like the ones Tesla hoped to use for wireless power. While his engineering assumptions and practical expectations did not fully match later scientific and technical realities, the underlying idea that Earth behaves as a resonant body in the electromagnetic sense is confirmed in more rigorous form. Planetary magnetic fields, plasma waves in space, and oscillations in astrophysical systems all demonstrate that vibration and resonance are not human projections, but real, measurable dynamics. Even the concept of a vacuum has been transformed. Where classical physics once imagined empty space as a simple void, quantum field theory now treats it as a ground state rich with fluctuations. Virtual particles, zero-point energy, and non-trivial vacuum structure indicate that what appears empty is, at a deeper level, active and structured. Tesla's talk of a subtle medium or ether filling space was not compatible with the specific ether theories rejected by relativity, but his intuition that space itself is not mere nothingness finds a distant echo here. While modern physics builds this picture mathematically rather than through Tesla's mechanical analogies, the philosophical shift is similar. Apparent emptiness hides complex energetic behavior. For you, this may change how the phrase vibrating living universe is heard. It no longer has to be dismissed as a mystical slogan. Instead, it can be understood as a narrative shorthand for a reality in which fields, waves, and oscillations govern structure at every scale. Your own brain operates via electrical activity that can be analyzed in terms of frequency bands. Your heart rhythm is a periodic signal. Your circadian cycles are entrained to planetary rotation and light patterns. Biological systems are full of oscillators, feedback loops, and coupled rhythms. When these rhythms are coherent, systems function efficiently. When they fall into disorder, pathology emerges. In this sense, life itself can be seen as a delicate choreography of synchronized and desynchronized vibrations. Tesla's personality added another layer to his vision. His eccentric habits, strict routines, and extreme sensitivity to light and sound can be interpreted, in part, as the traits of a nervous system keenly attuned to subtle stimuli. He dined at precise times, obsessed over numbers, and demanded symmetry in his environment. To some, these behaviors appear purely obsessive. To others, they suggest a mind attempting to live in conscious alignment with patterns it perceived as fundamental. Whether or not that interpretation is fully justified, it is clear that Tesla saw no sharp boundary between the abstract laws of physics and the concrete details of daily life. To him, both were governed by the same underlying principles. This bridging of inner and outer worlds resonates with certain strands of contemporary thought that explore how physical processes give rise to consciousness. While Tesla did not construct a formal theory of mind, his notion that thought might be a form of finely structured energy interacting with a wider field prefigures some speculative ideas in neuroscience and information theory. Brain dynamics are often modeled as networks of oscillators with patterns of synchronization and desynchronization correlating with different cognitive states. External stimuli, from rhythmic sound to patterned light, can entrain these oscillations. In a very literal sense, your nervous system is continuously being tuned by the environment. In this light, Tesla's belief that inspiration could strike like a sudden complete vision becomes easier to contextualize. If the brain is a complex resonant system embedded in broader informational and energetic fields, then certain configurations of internal and external conditions might indeed produce rapid, coherent reorganization, what is subjectively experienced as a flash of insight. Science does not need to invoke anything supernatural to describe this. Nonlinear dynamics and complex systems theory provide a vocabulary for how small changes can trigger large, organized shifts in system state. Tesla's language of waves, currents, and vibrations in thought becomes a metaphorical precursor to these more formal descriptions. Technologically, the world has moved in directions that simultaneously fulfill and ignore Tesla's vision. Alternating current power systems, arguably his most consequential contribution, have become the backbone of modern civilization, quietly encoding his understanding of rotating magnetic fields, phase relationships, and efficient transmission. Radio, wireless communication, and high-frequency electronics all operate within the conceptual territory he helped open. Yet the broader dream of harmonizing with planetary-scale resonances to distribute energy in elegant, low-loss ways has not been realized as he imagined. Instead, centralized grids, fossil fuel infrastructures, and fragmented systems dominate, often designed with local optimization in mind rather than global energetic elegance. You can see this contrast in the way society discusses energy today. It is usually framed as a commodity, quantified in kilowatt hours, barrels, and joules, rather than as a manifestation of underlying cosmic structure. Efficiency is pursued through incremental engineering improvements rather than through rethinking systems around resonance, coherence, and long-term stability. The culture tends to separate physics from philosophy, engineering from ethics, and technology from a larger sense of planetary balance. Tesla's universe, by contrast, allows no such simple separations. If everything is connected through fields and vibrations, then technical decisions inevitably have systemic, long-range consequences, whether humans acknowledge them or not. There's also a cultural dimension here. Tesla's image has been appropriated in many directions: science icon, misunderstood genius, symbol of free energy, quasi-mystical prophet. Amid sensational claims and speculative narratives, the underlying core of his thought can be overshadowed. Yet that core remains remarkably clear. Reality is structured by energy and frequency. Systems respond most powerfully at resonance. Nature favors coherent patterns over random disorder, and human technology should ideally align with these principles rather than fight against them. Stripped of exaggeration, this is both a scientific and philosophical stance. For someone trying to make sense of their place in the universe, Tesla's vision offers a demanding form of responsibility. If you accept that you exist within a web of resonant interactions, then your actions are not isolated events, but perturbations in shared fields. The way energy is used, the signals sent into the environment, the rhythms maintained in personal and collective life, all of these participate in shaping broader patterns. In this sense, understanding energy, frequency, and vibration is not merely about building better machines. It is about recognizing the conditions under which systems, technological, ecological, and psychological, remain stable, adaptive, and alive. The unresolved question is whether humanity will choose to treat this vibrating, living universe as a partner to tune with, or as a background resource to exploit, without regard for resonance and long-term coherence. Will future science and engineering embrace Tesla's deeper intuition, integrating rigorous mathematics with an awareness of systemic harmony? Or will it continue to prioritize short-term output over alignment with the fundamental patterns of a resonant cosmos? Current global energy and technology paradigms remain largely non-resonant, operating as fragmented high-entropy subsystems that disregard coupled field dynamics and holistic stability criteria.